In this tutorial, we're going to take a look at some common measurement problems involving three-dimensional solids that you kind of see in everyday life a lot. So we're going to start with this first one. This is a rectangular, we would call this a rectangular prism, same as a room in your house. Most would be that shape. So we're told that this room measures 10 foot 3 inches. We would probably call that the width. It's 12 foot 7 inches long, and the walls are 8 feet high, which is very normal. So we're asked to find how much paint is needed to cover the 4 walls with 2 coats of paint. And then we're told that a can of paint covers about 400 square feet, so we're asked to find out how many cans you need. And then there's the cost per can, so including tax, HST is 13%. What's the total cost going to be to put 2 coats of paint on this wall? In just paint, no labor. So first of all, we'll start by finding, now we're going to find the area of the 4 walls. So that's part of the surface area of this prism. Because these are in feet and inches, we're going to convert the feet and inches into decimals of a feet, so 10.some feet, 12.some feet. Remember that there's 12 inches in a foot, not 10. So 10 foot 3 is not 10.3 feet. 12 foot 7 is not 12.7 feet, okay, because there's 12 inches in a foot, not 10. So the first thing that we're going to do is I'm going to take this 3 inches here and I'm going to divide it by 12. I'm just about to bring my calculator over here. 3 divided by 12 is 0.25. So that's the decimal part. So this is going to be 10.25. Now just to show you, you might have someone else show you this instead. So we could figure out how many inches this is altogether. We could go 10 feet times 12 inches in every foot plus the 3 inches. So that's actually, like if you had a tape measure and you laid it out there, that's 123 inches. And if we take that 123 inches and divide it by 12, so there's another way to get the 10.25 feet. We could do the same thing up here. We could go 12 times 12 feet times 12 inches in a foot plus the 7. So that's 151 inches along there. So 151 divided by 12. So this is about 12.58. What I'm going to show you here in a second is actually, you could just take the 7 and divide it by 12 inches. So there's the 0.58. So that 12 is the 12 feet, and then the 0.58 is the 7 inches. So there's the 7 divided by 12, so this is 12.58 across here. So we need it in decimals so that we can use our calculator, because you can't type in your calculator 10 feet 3 inches for a multiplication. So this is the surface area formula for a rectangular prism. Now we're just painting the 4 walls. This would be the floor, this would be the ceiling. We don't normally paint the floors, especially not the same as the walls, and the ceiling is often a different color than the walls. Often we paint ceilings white and the walls are a different color. Not always, but sometimes. So this W length, W times the length, width times the length, that's the floor. This is the ceiling. So that 2WL is the floor and the ceiling. So we're going to get rid of that. We do not need that. This is going to be the 4 walls. So we're going to put, I'm going to use 12.58 for the length of the room, 10.25 for the width, and the height is 8 feet. So we're going to fill all that into the formula here in place of W, H, and L. So that's what it would look like. And so let's bring the calculator back here. So at the beginning here we have 2 times 10.25 times 8. So that's going to be 164. And then 2 times the 12.58 times the 8 on the end. So that's 201.28. And then we'll add those together, plus 201.28. And so that is the area of the 4 walls. So there's the calculations I had here. Now, before we get into how much paints we're going to use, if you're ever working for a painter or maybe a carpenter, they might show you a little different way to find the area of the 4 walls. Okay, and this is a little different way to do it. Find the perimeter of the room. Add up these 4 dimensions, or you could look up here, it doesn't matter, same thing. So it's kind of like you're opening this up and we had this big rectangle that's made of the 4 walls. So see, that's 12.58, 12.58 times 2. So that's like that dimension plus that dimension. And we're going to add in the 10.25s here. So add into that 10.25 times 2. So that would be the distance around the room. And then if we multiply that by the height, the 8, we will get exactly the same area. Okay, so that's another way to get what the area of the 4 walls would be. So now, how much paint is going to be needed? We're doing 2 coats, so we need to double this. So we'll take the 365 and 365.28, and we're going to multiply that by 2. So, and just to show you what that looks like, so the 365.28 times 2. So, and to the nearest, I'll round it to the nearest whole number, that's why I rounded to 731. So square feet, that's how much paint we need to cover the walls with. So now we're told that, so that's how much paint we need to cover. So a can of paint covers 400 square feet. So B here. So what we would do is we take that 731 and divide it by 400. We want to find out how many 400 square foot cans we need to cover 731 square feet of walls. So we'll divide that by 400. So 1.8275. You can't buy part of a can, so we would round that to 2. So we need to buy 2 cans of paint. So for C here, what we'll do is we're going to take that 2 cans of paint and multiply it by, see, each can is $48.99. So that's the cost of the paint before tax, $97.98. So now we're going to add in the tax. So we're going to find 13% of that. So we take the $97.98 and multiply it by 0.13. So that's the tax, be $12.74, around 2 decimal places. So there's the calculation. So we would be adding the $97.98 and to that $12.74 tax, so $110.72 would be the final price including tax. Now I do want to show you a little different way to do this calculation. So this is the amount that we're adding tax to get the final price. Because we're finding 13% and then adding that on, finding 13% and then adding that 13% on is the same as finding 113% of something. So here's a shortcut. If you're ever working in a store, this might come in very handy. So if you take that and multiply it by 1.13, so that's the 113%, then that gets you directly to the 110.72. See, that 7 would make that round up to a 2. So if you don't need to figure out the tax separately, the 12.74, if you want to just go from this is what it costs plus the tax gives you 110.72, then that is a shortcut for doing that. Okay, example number 2. So Fred wants to finish his driveway with concrete pads. Not going to pave it, he's going to use concrete pads. So when pouring concrete, you don't make one big pad, because especially if you're somewhere where it freezes in the winter, then it will crack over time. So what they do is they make smaller pads. We're going to make these 5 feet by 5 feet and 6 inches thick. And there's several of those. So the pad itself might be able to heave a little bit, but because it's not the entire driveway, it's less likely to crack. Not that it can't, but it's less likely to. And we're told that his driveway measures 20 feet by 30 feet, so we can use that to figure out how many pads he needs. That's B. And then this is what it costs per cubic yard, including tax. What's this going to cost to buy all this concrete? So first of all, like the last problem, this is in feet, but we got this one in inches. So we need to convert that into a decimal. So if we take the 6 inches and divide it by 12, because there's 12 inches in a foot, that's 0.5 feet. So 6 inches is the same as half a foot, 0.5 feet. So let's put a 0.5 feet right here. So now we've got the dimensions, the length, width, and height all in feet, decimals of feet. And so How much cubic feet are, now cubic feet, that's volume. Okay, so we want to find, A is really asking, what's the volume of one of these concrete pads? So here's the volume formula. Volume of a rectangular prism is length times width times height. So we'll fill in that we would probably call the length and width 5s and the height 0.5. This is probably the height of your prism here. So 5 times 5 times 0.5 is 12.5 cubic feet. That's how many cubic feet each of these pads would use to make one of these pads. So in B here, we got to figure out how many concrete pads he needs. So here's a diagram of the driveway. It's 30 feet long, 20 feet wide. I divide it up into 5 by 5 squares. See, 30 divided by, see, each one is 5 long. 30 divided by 5 is 6. 1, 2, 3, 4, 5, 6. We could go 5, 10, 15, 20, 25, 30 for the length. And then it's 4 wide. 5, 10, 15, 20, or 20 divided by 5 gives you 4. So there's 4 this way, and there's 6 this way. So 4 times 6 works out to 24. So Fred needs to make 24 of these concrete pads to pave his driveway. So for C here, now let's get into the cost. There's 24 pads, and each one takes 12.5 cubic feet of concrete. So we would multiply 24 by 12.5. I mean, if you really want to do this long way, you could go 12.5 plus 12.5 plus 12.5 24 times, but multiplying is a lot quicker. So he needs 300 cubic feet of concrete to complete this job. Now, normally concrete is sold in cubic yards. And actually, if you're ever working for a contractor, they won't normally use the terminology cubic yards. They'll often refer to it just as a yard. A yard of concrete is actually a cubic yard of concrete. Okay, so they probably won't say cubic very often. It's usually just a yard. So we need to convert. We've got cubic feet here, but it's sold by the cubic yard. So I'm going to show you 2 ways to convert this. A cubic foot is 3 feet by 3 feet by 3 feet. So there's 27 cubic feet in a cubic yard. So if we take the 300 and divide it by 27, then Fred needs about 11.1 cubic yards. The company that makes the concrete will ask you, well, how much do you need? So I know how much to send you in the trucks. So that's why he needs to know what that amount is. Now, another way to do this is you could use a proportion. 1 yard is the same as 3 feet. That's a linear relationship. And we're doing cubic measurement here, so that's why they're both cubed. He has 300 cubic feet, and X is the unknown. We're trying to figure out how many cubic yards he needs. So I'm going to drop all the units here. 1 cubed is 1, 3 cubed is 27. See, this is just feet cubed. The 300 isn't cubed. That's just a unit here, so the 300 is still 300. And here's my x. So I'm going to cross multiply. So 27 times x would be 27x, and that would equal the product of 1 times 300. So to isolate for x here, I would divide out the 27. So if I divide out the 27, they divide out, and we divide 300 by 27, same thing we did up here, to get 11.1 cubic yards of concrete. So, to figure out the cost, 120 times the 11.1s. Each of these costs $120. So we would go, I guess I didn't show the 300 divided by 27 was 11.1. There's my 11.1. So we would take, now you shouldn't round this to 11. If you need 11.1, you shouldn't order 11 because you're probably going to be a bit short on your last one. So you should really order 12 cubic yards. Maybe you have a little bit left over, use it for something. So 12 times $120 for each one of those. So $14.40 is what that's going to cost, and then we want to add tax. So remember the shortcut I showed you on the previous page? Times 1.13. Actually, let's okay. So that's the total. Let's going to cost them that. And of course, if you want to do it the long way, the longer way, not really that long, I guess, you could go times 0.13, especially if you're filling out an invoice and need to know that there's $187.20. So if you take the 1440 and add that 187.2, gives you exactly the same number, $1,627.20. Example number 3. Farmer Joan wants to buy a silo that will hold at least 175 cubic meters of grain. The one she's considering is in the shape of a cylinder with a hemisphere on top. That's the shape of silos a lot of time. So we're told that the cylinder is 3 meters in radius and it's 5 meters high. We're asked to determine whether this silo will suit her needs. Okay, is its volume at least 175 cubic meters? So we're going to find the volume. We've got two different shapes here. We're going to find the volume of each one separately. So for the cylinder volume, that's the volume of a cylinder. We're given the radius is 3 and the height's 5, so we'll fill in those in place of the radius and the height. So pi times 3 squared times 5. So this works out to about 141.4. Now we need to do the hemisphere. So this is the volume formula for a sphere, and we're going to multiply it by a half because a hemisphere is half of a sphere. So when you multiply this, if you look at the fractions, we're multiplying 4/3 by a half, so 4 times 1 is 4 on top, 3 times 2 is 6 in the denominator, and I can simplify this because I can divide a 2 out of both of these. 2 goes into 4 twice, 2 goes into 6 3 times. So that's actually the volume formula for a hemisphere. See, if that's the volume for a whole sphere, if it's 4/3, well, 2/3 is half of 4/3. So that's our formula. So we're going to put 3 meters in place of r. And so this is what the calculation will look like. So 2 pi times 3 cubed and then divided by 3. So this is about 56.5 here. Oh, I did show the entire calculation right. Let's get rid of the divided by 3. Okay, so that's the number in the numerator. That's where that came from. And of course, just dividing that by 3 gives us the 56.5. So now we want to add these. This is the volume of the cylinder. This is the volume of the hemisphere on top. So 141.4 plus 56.5. So almost 198 cubic meters is what this would hold. So it will suit her needs because the volume is larger than 175. So it should be fine for what she's using it for. Example number 4 here, the Highway Friends Construction Company, they plow and sand local highways in the winter. And in one of their yards, they have this pile of sand that is very closely in the shape of a cone. It's 4.5 meters tall, and it's 5.8 meters in diameter. So we're asked if their trucks can hold 6 cubic meters each, how many trucks can they fill with this pile of sand? So first of all, if it's 5.8 meters in diameter, for the formula we need the radius. So if you divide that by 2, so if we take 5.8 divided by 2, then that's why the radius here is 2.9 meters. So how much will something hold? That's volume. So we'll use the volume formula for a cone here. So substituting in the radius is 2.9 and 4.5 meters is the height. And so that's the calculation that we're going to do here. So pi times 2.9 squared times 4.5. So the calculation on top is going to be 118.89, and then we're going to divide that by 3. And of course, if you divide that by 3, That's where the 39.6 cubic meters comes from. So that's the volume of the entire pile of sand, and each truck can hold 6 cubic meters. So we would take that 39.6 and divide it by 6. So it works out to 6.6. So it's going to take 6 trucks and a little more than half of one. A seventh truck is going to be a little more than half full. So there's the calculation. I just showed it in my Texas Instrument calculator. So 6 full trucks and another one about half full, or just a little more than half full, to haul away that entire pile of sand. Last example here. Geoff owns a construction company, and his company has been asked to build this art design. And it's supposed to be made of solid concrete. So, and you're asked how many cubic feet will he need. So now you can probably, we're not worrying about but there's probably a metal rod in the middle here that's going to connect the two together. Because obviously if they're just concrete and just touching by a tip here, that's probably going to fall over, and well, that would probably kill someone if it fell on them. So we're not worrying about the rod, but there would certainly would have to be some kind of a support here. We're just tasked to find how much concrete, how many cubic feet of concrete he's going to need. So how many cubic feet he's going to need, that's volume, because we're filling it with the concrete. It's not like we're just painting it. If we are asked how much paint will it take to paint the thing, then that's surface area. So we're going to do a volume calculation here. So let's start with the cone first. That's the volume formula for a cone. And so we would substitute 2 feet in place of the radius and 3 feet in place of the height. And so that's the calculation. So let's bring up the calculator here again. So pi times 2 squared times 3. So in the numerator here, we're going to have 37 point almost 7, and then we're going to divide it by 3. So that's work out to be about 12.6. So there's the 37.7 number, and so 12 cubic feet. That's the volume. How many cubic feet of concrete you'll need to fill the cone. So let's do the square base pyramid here on top next. So there's the volume for a square base pyramid. The B's are the dimensions of the base, the square base. So we're going to put 2 here, and 3.5 feet is the height, so we'll put it in place of h here. And so 2 squared times 3.5. So in the numerator we're going to have 14, and then we're going to divide that by 3. So 14 divided by 3 works out to be about 4.7. So 4.7 cubic feet for the square base pyramid on top. So in order to figure the total volume, then we would add the volume of this one and the volume of the cone. So we add 12.6 and 4.7. That works out to 17.3. I guess I'll just demonstrate that. 12.6 plus 4.7 is 17.3. So just to answer the question, Geoff needs 17.3 cubic feet of concrete to make this structure. And that's the end of the video.